between nucleons. Okay. These are the areas which we have in nuclear forces. Okay. Now, the next point I thought of discussing the next one as about a nuclear process called nuclear fission. Now, fission, you must be familiar with the term fission. Nuclear fission is nothing but splitting of nucleus into two lighter fragments. You know, the nucleus has got there is a tendency of the nucleus to be unstable. A nucleus, instability of nucleus is what actually we discuss in the concepts of radioactivity, which we will take up in the next segment. Okay, the instability, that is radioactivity, that we will see. But certain nuclei, a typical example is uranium-235. Now, certain nuclei have got very what you call as, there is a delicate balance between the nuclear between the forces inside the nucleus. There is a delicate balance. So, what do you mean by the delicate balance? Delicate balance means whenever there is some small disturbance happening, it will become completely unstable. That is meaning of delicate balance. Okay, so that is a for example, if suppose somebody is very much sad and is sitting and just about to cry, let us say, it is a delicate situation. If he is about to cry for something, maybe he got low marks or something, okay, about to cry, and we are trying to console him or her, no problem, leave it, we will make up later. If that is the case, then that is a delicate situation you disturbed. So, that what can happen, the person may get into tears or may cry. Okay, so, the delicate balance is disturbed. So, uranium-235 is a nucleus which has got a delicate balance between the forces. So, to that, if you are bombarding a neutron is the one which is disturbing the delicacy, the delicate situation. Okay, so, when neutron is used to bombard into the nucleus of uranium-235, what happens is it will split into fragments. So, these fragments, splitting into fragments, will cause a lot of release of energy. How the energy comes out? Remember, in any nuclear reaction in that matter, the release of energy is always due to the loss of mass. After the reaction, some amount of mass will be lost as a whole when compared to what was there before. So, this difference in mass is getting converted into energy. According to Einstein's mass energy relation, you must be familiar with that. E is equal to mc squared. So, we see that the nucleus is always there is some energy when nucleus splits into fragments. What happens is nucleus becomes two fragments, plus along with that what else happens is it will be converted into or along with 2 or 3 neutrons also will be released. As a result of that, the whole nucleons or the whole mass would be decreased. So, this loss of mass is converted into energy. So, what is nuclear fission? It is a phenomenon of release of energy from when a nucleus is bombarded with a neutron and splits into fragments, right. And that I will show you one small simulation related to that. See, that is another thing I will show you. In fact, nuclear fission is or can be demonstrated using a small simulation. You can have a look at the simulation now. See that. See, this is uranium-235 nucleus, you can see that, right. Now, I am going to bombard uranium with a neutron. See, neutron. What happened is it splits into 2 fragments. See, the energy part is what is shown below this. So, once again I will show you, I will just pause it in between. So, what happened is when it is bombarded with a neutron, it splits into, you see, splits into 2 nuclei and 2 or 3 neutrons also you can see. Here these are the neutrons. So, this will release lot of energy. This process is what is called nuclear fission. So, nuclear fission, process of release of energy due to the splitting of the nucleus into fragments and along with release of neutrons as well. See, once again I will show you what is a nuclear fission reaction. Okay, so this is once again, yes, that is it. This is nuclear fission. Now, if one see, now one thing we can make out is there are many nuclei are there, say 235, uranium 235, suppose many nuclei are there. Okay. So, what is happening over here is I am going to bombard one neutron, a neutron, I am going to bombard a nucleus with one neutron. Okay. See what is happening, the neutron gets into the uranium 235 and it will split into many fragments. Okay. So, now in fact, I will increase the number of nuclei. Yes. You see what is happening. Look. Yes. What did you observe here? Splits a nucleus into many nuclei, right? Many nuclei, many fragments, and more neutrons are also released. Those neutrons will again cause nuclear fission on other nuclei, and tremendously high amount of energy would be released in a short span of time. This is called chain reaction. Once again I will show you chain reaction. Carefully watch it. You can see I am going to bombard one uranium with a neutron, and this neutron will split the uranium 235 into two fragments and three neutrons. And what these three neutrons do, just see. I'll in between I will what to say, pause it. See, now you can see this. See what is happening is many neutrons also released. They will cause fission again and again. Can you say where is it made use of? This chain reaction now, this chain reaction is what is made use of basically wherever we require large amount of energy. So, first thing, this amount of energy release is what is happening in a in a large scale energy is required. Whenever energy is released in a large scale, what will happen? There will be complete destruction, right. So, this chain reaction is what is or uncontrolled chain reaction is what is made use of in where? In atom bomb. You might have heard of this one. In Hiroshima and Nagasaki, you might have heard of the explosion of atom bomb in those two places. So, the atom bomb caused a lot of destruction and released a lot of harmful radiations as well, and what you say, that is one of the ways energy released in a short span of time is utilized initially, unfortunately. Okay. So, the case of chain reaction is initially utilized for the destruction purpose, that is atom bomb. Okay. So, later on people think that okay, so much of energy is released in a very short span of time, then why can't you use it for a useful purpose? This is for destruction it is used, right. And this release of energy, if it can be utilized in a proper manner, it is a very big boon to the humanity, because we are always in energy crisis. So, the energy released in this way can be controlled. The problem is that uncontrolled chain reaction means we cannot, like once if it is initiated, you have seen it keeps going like that, so cannot control. So, if you want to use it for useful purposes, what is required? We should control it. How we will control it? We will discuss how we will control. We will see that after a short break. After a break, we will come back and we will discuss the details of how do we control the chain reaction. Stay tuned. We will see after break.
In association with
Atlas Group of Institutions, expanded with its new division. Atlas Group of Institutions, expanded with its new division. International College of Law, Business Administration and Technology, ICL Bath in Ajman.
AGI's Atlas International College Free Zone, Ras Al Khaimah.
Provides
Undergraduation BCom, in BBA, in BCA, BMN, BSc.
University of Madras, University of Calicut and Atlantic International University from the USA.
Co-sponsored by Dr. Dinesh Karta's Aura Ayurvedic and Yoga Center. Ayurvedam Yoga Acupuncture ചികിത്സകൾ ഒരേ കുട കീഴിൽ. Kohinoor Gems, Well of Natural Gems. Our renowned gem consultant R. Babu Narendra For more details, contact 0435 84484 050 910 9360. Kohinoor Gems, Dubai, UAE. www.babunarendra.com.
Bluebell Medical Center. മിതമായ ചെലവ്, ശരിയായ ചികിത്സ. ബ്ലൂബെൽ മെഡിക്കൽ സെന്റർ, അല്ലത്താർ ബിസിനസ് സെന്റർ, സ്വീറ്റ് നമ്പർ 3.